everyone, my name is Anaiya Raisinghani, and I'm an Associate Developer Advocate over here with MongoDB. Anyone who fantasizes about luxury knows all about Net-A-Porter and the amazing pieces that the website offers. While my normal approach is sorting from low to high by price, I would be lying if I said it wasn't incredibly fun to see the full range of what the website offers. So let's use a fun dataset that holds last season's Net-A-Porter items and semantically search to explore some of the most expensive items from any brand, any category, and with natural language queries. In this tutorial, we are going to be using MongoDB Atlas, the PyMongoArrow library, MongoDB Atlas Vector Search, and of course, our fun luxury dataset from Kaggle. Before we dive in, let's just go over some of the really important aspects of the platforms that we are going to be using. So what is PyMongoArrow? PyMongoArrow is a Python library for data analysis with MongoDB. Due to our dataset being a .csv file, we are actually going to be reading it in as a pandas library, so it'll be read in as a pandas data frame. With the PyMongoArrow library, we can export all of our data to MongoDB Atlas in the most ideal format for our tutorial. It's actually built on top of PyMongo, so it allows us to work with MongoDB data in a super easy and performant manner. As you work through this tutorial, you will see how simple transferring your data and configuring it becomes when you're using the PyMongoArrow library, which is an issue many data scientists have had in the past. So what is MongoDB Atlas Vector Search? MongoDB Atlas Vector Search has actually really revolutionized how you can search because it lets you search semantically through your database while keeping all of your vector embeddings right next to your source data in the same database. Searching semantically means to search by meaning instead of searching by using exact keywords or phrases. So this means that we can query and receive results that convey the same idea without that precise wording. For example, instead of searching through our sample size using simple queries such as dress or skirt, we can actually use phrases or generalities such as like summer, beach, tropical, or just even summer. We are going to be utilizing the $sign vector search aggregation stage in this tutorial, which will make things even a little bit easier. So let's go over some prereqs in order for us to be successful during this tutorial. Our first one, of course, is using an ID of your choosing. We're going to be using Google Colab in this tutorial. And then, of course, you need a MongoDB Atlas account. You need to set up a MongoDB Atlas cluster, and the free tier works perfectly fine for this tutorial. Then we need to download a dataset from Kaggle. You can follow along with the same one that I used. And then you're going to need an OpenAI API key in order to embed all of your documents. And links to everything will be in the description box below. Perfect, let's get started. So once your cluster has been created and you've downloaded the dataset locally, we are ready to begin the tutorial. So our very first step is to actually upload our .csv file into Google Colab. And before we upload that, I just want to point out, for this tutorial, I have added in a lot of comments just to make things a little bit easier because we are going to be doing a lot of really cool stuff in this tutorial. So I've left a couple things like our get pass prompt because I know that that is not a part of our written tutorial if you are following along. And that's just to keep things secret and safe while I am doing this live. So we have our vector search index and then just some comments that we're going to fill out to make things a little bit easier for you and for myself. So once again, our first step is to just go ahead and actually upload our .csv file that we downloaded from Kaggle. And so we can just go over here, click that little arrow, and we can go over and find it with Net-A-Porter.csv. Perfect. And that's okay. We can hit OK. Awesome, it's downloaded in. So once your file is uploaded, we actually need to do two very important things. Our first step is to use OpenAI to create embeddings on each item in our file. And our second step is that we actually need to clean up our data set and reconfigure it into a format best suited for our end goal. So this is just to ensure that we can actually use semantic search to find any items that we want inside of our database, and we can find any luxury items that our heart desires. So if you're going to take a look at our CSV file right over here, you'll notice that it actually consists of 4 columns. We have brand, description, price in USD, and type. And then there are a multitude of rows. I'm not going to scroll through all of them, but you can get the idea. You can scroll through it yourself. So we need to add a column inside of our data frame that actually contains the embeddings for each of our item descriptions. This is going to allow for us to search semantically based off of the item description. So to embed each item, we are actually going to be using our text embedding 3 small embedding model along with this embedding function right over here. We also will need to use the pandas library to work with the data that we have on hand. And if you are a data scientist or you've worked with Python and data before, I know that you probably know pandas, but for those that are new to it, pandas is actually a Python library used for working with data sets. And it's super crucial when analyzing, cleaning, exploring, and manipulating data. And as you're going to see, it makes our work a lot easier just to get to the parts of the data frame that we want to use and to get the data that we most desire. So to start off, we first have to install OpenAI. So we can do this with a very simple pip command. And then we can run that, make sure it works and downloads. Perfect. And then I've already put in our imports up top over here. So we're just importing pandas as PD. We're importing OpenAI because we just installed it. And then we're going to be importing getPass as well. So talking about keys, make sure that you take a second and just grab your OpenAI secret key. And then we are going to fill out some of these handy little comments that I've already created. So the first one is we are going to be using this embedding model for text. So we can just do embedding model. Once again, it is the text embedding 3 small. And then the embedding function, I'm just going to copy and paste it from up top. It's right over here. Perfect. So we have set ourselves up for success with processing our embeddings. So let's go ahead and actually configure our data frame. The first step is that we really want to read in the file that was just uploaded. There's no point in uploading a file if we're not going to read it in, right? So let's just do df for data frame pd csv. And so here we're just using pandas to read it in. And we can go in and say content/net porter.csv. Cool. And now we only really want to focus on the first 3 columns. And that's just because I personally feel like we do not need the type column. As you can see here, for a large majority of the items in our data set, the type is clothing. But besides that, it just gives like shoes, accessories, stuff like that. So I am personally just going to drop that column. If you want to use that column in yours, no worries at all. But I'm just going to drop it to make things a little bit cleaner for ourselves. So df.drop. And then from our columns, we want to drop type. Perfect. You can do in place is equal to true. Very nice. So that we're down to our 3 columns that we want to use. It is important to make sure that the columns that we are dealing with are clean and don't have any null values at all. So this is crucial because null values can actually mess up our data in the long run. And it's just really good practice to always ensure that you're working with a clean data set. So to do this, we're going to use something called dropna. Do df.dropna. And then subset is equal to, this is specifying the column that we want to drop the null values from. So we are going to do brand and then price USD. And then we're also going to do our description. Perfect. And then once again, just hit it with the in place, true. So now to ensure that we are not spending a ton of time or money, just resources in general, embedding the entire gigantic CSV file, I'm just going to cut it down to 100 rows. That'll still give us a pretty good sample size of data to work with, but it's not going to take up a lot of our resources. And we'll still get the same idea, whether we only embed 100 descriptions versus the probably thousands that are in that .csv file. So this is just simple. It's just df is equal to df.head and then 100 to just splice it down. Now what we have to do is we have to create a new column that we're going to put into our data frame that contain the actual vectorized embeddings. So we can do this by just going tf is description. So this is saying that we're going to have a new column called description embedding, and that taking it from the description, and then we want to apply our embedding function. Awesome. And then we're just going to print out the first 20 rows just to make sure that we're on the right track. So df.head and then 20. Very nice. Okay, cool. So let's run it. And once again, the expectation for what's going to come out of this section is that we are going to have 4 columns, but we're not going to have the type column anymore. And instead of the type column, we are going to have a description embedding column with all of our descriptions embedded as vectors. So let's run that and see if that works. Perfect. So let's enter that in. Awesome. So as you can see, we have a data frame with the columns that we need, which are brand, description, price in US dollars, and description embedding, which is our description column as vectorized embeddings. So our next step is to actually save this data inside of MongoDB Atlas so that we can use MongoDB Atlas Vector Search when we're ready to do so. And we can do this very easily by importing our data into Atlas using the PyMongoArrow library. So the really cool thing about PyMongoArrow is that it actually uses Apache Arrow behind the scenes. So to move our data into Atlas, we need to convert our pandas data frame into an arrow table. And the great part about arrow tables is actually that they allow for nested columns. So if we did have a more complicated data set, we wouldn't need to jump through too many hoops to accommodate nesting. So let's go ahead and get started. Our first step, of course, is to actually install everything that we need. I'm just going to use a pip statement and install PyMongoArrow, and then PyArrow. Perfect. And then these are imports. So from PyMongo, we're going to be importing Mongo client. From PyMongoArrow.api, we're going to import a write feature, which is going to write our data frame into MongoDB Atlas, and some magic is going to happen. And every single row from our CSV file is actually going to be turned into a document. So you're going to see that in a second. And then we're going to import PyArrow SPA. And before I forget, let me run this actually and make sure everything gets installed. So sometimes this happens where we have to restart the runtime, and that's been happening a handful of times, but it's not a problem at all. We just click restart session, and then we can just go through and actually rerun everything that we've already run. I like to just do everything just to make sure. So once that succeeds, we can actually sort our items by most expensive to least expensive. And that is just a personal preference, and that's just for fun for this tutorial. Especially when luxury shopping, sometimes it's fun to see the most extravagant items. So that's what I'm going to be searching based off of. And then also a very important part is please ensure that you have your MongoDB connection string. I'll show you how to grab that in a second if you haven't done that before. But once again, if you're doing this in production or you need more security, please keep these secret values in a .n file for the sake of the tutorial, and just for simplicity purposes, I am using getPass to input my variables and my secrets. So let's first sort by most expensive items to least expensive. So df is equal to tf.sort values, and we want to sort by. So it's nice that we already have our price as a column, and then we want to do ascending, and that is going to be false. So if I want it to be the other way around, of course, it would be ascending true. And then this is where our connection string is going to go, and we can just write our clients, Mongo client, and then connection string. Perfect. And once again, you can really just name your database and collection anything that you like, because we've created the cluster, but we haven't created the database in the collection. So when we do write in our data frame using PyMongoArrow, into Atlas, that's when our database and our collection are going to be created. So we can name it whatever we like. I'm just going to do database equal to client, and that's going to be neps order. And then I want to have my collection be equal to database, and then that is also going to be, I'm just going to name it average prices descending. Perfect. So in order to save our data, we first do need to convert our pandas data frame to an arrow table using PyArrow. So we can do that just with arrow table is equal to table from pandas, and then we're put in our data frame. Nice. And now we can use that little write. So we can go write, and then we want to write in, collection, arrow, table. Very nice. And now we can just do a print just to make sure that it worked. I'll just say successful. And then I'm also going to show you if it is successful, which fingers crossed it is. I'll show you what it looks like in Atlas with all of our documents. So let's run this and then see what happens. Oh yeah, so first let's put in our connection string. So go over to MongoDB Atlas, hit connect on your cluster, go to drivers. We're using Python, of course. So I'm going to copy that in. I'm going to take it off screen for a second, input my password right over here, and then copy and paste it inside of Colab. So my connection string has been copied and pasted in with my password inside of it. So let's enter that in. And it was successful. Awesome. So let's go over back to our cluster and let's go and take a look and see if our documents have actually loaded in. Nice. And as you can see, our database was created, our collection was created. We have a total documents of 100. Perfect, because we spliced down our entire data set. And as you can see, every single description, and not just the description, every single item inside of our database, well, the 100 that we spliced down, has been turned into a document. So we have our description embedding, which is the most important part. We also have the brand, we have the description of what the item is, we have the price, then we have the embedding, and we have that for, I believe, the first 100, which is awesome. So now that we have our embedded documents in place, we can actually set up MongoDB Atlas Vector Search. So to start searching semantically, what we're first going to have to do is create a vector search index. So I've left it over here just for clarity's sakes. So I'm going to go over and copy this and then go back to my cluster and go to Atlas Search. I'm going to go down here and hit Create Search Index. And we're going to be using Atlas Vector Search, of course. So click that and then click Next. The collection that I want to be doing this on is, of course, our average prices descending collection. I'm going to keep the name the same just because it's default and it's a little bit easier. But if you do change the index name, please follow that through the entirety of the tutorial. So let me copy and paste that in. And of course, if you remember from seeing the embeddings, because we're using OpenAI, the number of dimensions is 1536. The path that we created that we want to use this on is description embedding. And then similarity, we're using cosine, and the type, of course, is vector. So hit next, scroll down, create search index, close, and then let's just wait for this to turn green and tell us that it's active. Perfect. So once it's active, we can actually go back to our Google Colab file. And first, what we need to do to search semantically, we need to first embed our queries. So a lot of people struggle with this concept, but one of the most important things to take away from vector search is that we are not comparing text to vectors, right? We want to be comparing vectors to vectors. So of course we have to embed our queries as well. So this is very simple to do because we've already have used our embedding function before. So all we have to do is just name it something. I'm just doing query description, and then I want this to be, we can just do summer for now. I'll do summer and winter as my queries and show y'all what the outcomes are of both of those. So now let's embed it over here. We can do query vector is equal to the same embedding function from above, because we want to make sure that we're using the same model to embed not only our queries, but also our documents. So description Perfect. And now for kind of the more difficult part, or not difficult part, but definitely the longer part. I'll leave some documentation below on aggregation pipelines if y'all are not used to those, but we need to be using the $vector search operator and create our aggregation pipeline so that we can actually semantically search on our data. So in order to do that, we're first going to open up our brackets like that and use the vector search, $vector search, and then we can put in some information. So the first thing that we want to do is we want to define our index. So we just created that. So vector index, if you named it something else, this is where you'll want to put that in. If you left it default the way that I did, keep it as vector index. And then the path, and our path, of course, is just going to be description embedding. And then we have our query vector. So this is query vector from above. So I only had 100 rows saved, right? So we're just going to do num candidates. We'll have our whole sample size, but then let's limit it to 5. Awesome. So now we can begin our second stage. So let's open that up and we can use our project, because this is just saying like what fields do we want to show. So first things first, we don't need to show our ID. And let me actually go back to our cluster and show you kind of what we mean by this stage. So this is just saying like out of all of these fields that are listed, what do we want to see, right? So ideally, I don't want to see the ID. I don't necessarily care for the ID, but I do want to see the brand. I want to see the description. I want to see the price. I don't need the description embedding, so I'm not going to include that, but we are going to include one more thing called a score. So ID, we can have it equal to 0, and then brand, I want 1, and description, I want 1, and then price, I also want 1, and score. So with score, we can open that up and we can just do meta, vector search score. So that's just saying the vector search score, and I'll point that out when we run it. So now, next step and last step is just to sort it by price. So we can do sort and price USD. And once again, we want to sort by most expensive. So we're just going to do -1. Awesome. So let's just double check, make sure everything looks fine before we continue on. I believe it looks good. So let's finish things off strong. So we want to run it on our database and our collection, right? Okay, so we're going to do database is equal to client and then have net importer. Oops, nice. And then the collection that we're running this on, average price is descending. And then let's just do results is equal to collection aggregates. And we have our pipeline, just named pipeline. Perfect. And then let's print something, right? We want to see results. So result, just print clothing. Perfect. So let's run this and see what happens. Cool. So keep in mind, the query is summer. And when we're searching semantically based on our luxury items inside of our database, we are seeing 5 responses that are telling us that they're summer related, right? And they're going by most expensive to least expensive, still pretty expensive. And this is the vector search score right over here. Pretty cool. So as we can see too, one of the cool aspects is when we search for summer, we are seeing summer months show up as well. August, and things like shirts, midi dresses, mini dresses, maxi dresses, halter neck tops, all things that you would wear in the summer. So let's change the description to winter and see what happens. Perfect. Awesome. So all things that you would wear in the winter, things like ski jackets, wool wide leg pants, cashmere sweaters, cashmere hoodie and track pant set, more cashmere sweaters. Perfect. So try this out yourself and change the query to be whatever you like and then see what happens. So while this tutorial was done using a flat data set, once you truly understand each of the platforms used and the concepts, feel free to create a web scraper and try this on live data. And this tutorial just gives you a really great overview of what is possible with PyMongoArrow and MongoDB Atlas Vector Search. We were able to take a dataset, process it using pandas, generate necessary embeddings with OpenAI, store our newly developed arrow table into MongoDB Atlas using PyMongoArrow, and then we were able to semantically query on top of our database. For more information on PyMongoArrow, please visit the documentation, and for more information on MongoDB Atlas Search, please feel free to explore the tutorial that will be linked in the description box below. If you have any questions or want to share your work, please join us in the MongoDB developer community and drop a comment and like this video and let me know what you think. Thank you so much.